The other day I was planning an exotic vacation and I came into a math problem. Now I wanted to visit 5 cities, but I didn't know what order to visit them in, and I wondered how many possible ways could I visit those 5 cities?
Math, numbers,
Sine wave,
coordinates.
radius,
Let's factor. Let's factor more.
polynomials.
Welcome to Miss V's travel agency. No, math class. Miss V's math class.
Focusing today on problems that have the words "in how many ways can ...
This is an interesting problem because there isn't just one decision to make. There's actually 5.
I'm going to draw 5 different lines to represent my 5 decisions, and for each one I'm going to write the number of choices that I have for just that decision.
I have 5 choices of where I could go first because there are 5 cities. I have picked my first city. Now we're on to choice 2. Where should I go second? Well, I've already crossed one place off my list, so for my second choice, I have 4 options because there are 4 cities remaining.
For my third city, I only have 3 choices left, and so on and so forth. And the way that I calculate the total number of options is by multiplying all those numbers together. And in math, we actually have a shorthand way of writing this where we take an integer and multiply by every other integer lower than it until we reach 1. And this is called a factorial.
Let's look at some similar problems so that we get some extra practice.
New neighborhood is opening with 8 houses in a row. 8 families have already purchased the homes, and we want to know how many possible ways the families can be placed in the homes. Very similar to the last problem, I'm going to go ahead and draw 8 blanks and think about the number of choices for each decision. The first decision, I have 8 possible families to place in that house. So for the second house, I only have 7 choices. The third house, now I've used 2 of the families, so I only have 6 decisions, etc. And when I multiply all those numbers together, that gives me 8 factorial. Now, for the bigger numbers, like this question about a seating chart for 21 students, we don't necessarily need to draw 21 blanks. I can start to draw them, but I realize very quickly that there's a pattern. The first seat has 21 choices, the second seat has 20 choices, and so on, and this is going to continue down until there's only 1 choice left for the last seat. And so I automatically know that this is 21 factorial. Not every problem involving the number of possible combinations is going to be a factorial. There is a question about a true-false quiz with 7 questions. Now consider your first question, which is your first decision you have to make. You only have 2 options, true or false. So instead of 7, I'm going to write the number 2. Same thing for the second question, same thing for the third question. And what I come out to is 2 to the 7th power. It's important to remember that future ACT questions are never going to look identical to the past ones. So by preparing for the test, by going through past questions, you are familiarizing yourself with the concept, but don't expect to take the exact same steps for every problem. This next one is a good example of a question that's about a quiz, just like the prior one, but it's not exactly the same. Look carefully and see what the difference is. Multiple past ACTs have brought up problems having to do with combination locks and license plates, so it might be good to familiarize yourself with these. I encourage you to download these examples and look through them in detail, trying to work through each step as you go.
Helpful. If you have any questions, go ahead and leave them in the comments area and I'll get back to you.